This tutorial follows Chapter 8, Section 6, which is titled Independent and Dependent Events. And so let's take a look at what an independent event is. Basically, the book tells us it's an occurrence of one event has no effect on the probability that a second will occur. So I give you an example here. If a student spins a spinner and rolls a number cube, that's an independent event, because the two are independent because the spinner has nothing to do with the number cube. I could, let's say the spinner has different colors on it. I could spin a green and then roll a 1, and that would, the spinning of the green and rolling the 1 have no effect on each other. And so that's an independent event. Dependent events, though, are the opposite. So the occurrence of one event does affect the probability that a second will occur. And an example of that is a student picks a raffle ticket from a box and then picks a second one without replacing. And this is the key. And so whenever you don't replace something, then the probabilities change because we have less things left, less tickets in this case, to draw from. So the probability is greater on that second pick. And so that's what we're going to end up dealing with in this chapter, and we've got this section, and the first set of directions asks us to determine which event is independent and which one's going to end up being dependent. So we'll take a look at the first one. A student spins an even number on a spinner and then spins another even number on the second spin. So if you've got a spinner and basically they have a little rod here that is spun, and it goes around, and let's say it lands on some even number here. Let's say it lands on 4, this piece of the pie here. Well, if I go ahead and spin it again, does it landing on 4 affect the next spin? Well, let's say it landed on 2. Will that 2, landing on 2 here, affect the next spin? No. Spinning an odd number, I could then spin an even number, and I'd still end up with the same probability of spinning that next spin the same. And so it doesn't really affect the other. And so in this case, we would call this an independent event. And it's independent, and the reason is because the first spin does not affect the second. And so the key on these is going to be looking for if they do not replace something. So let's say I go ahead and spin it, and it lands on the 4, and then I pull off the 4, and that area doesn't count anymore. Then it would affect. So let's take a look at the next one here. John chooses a book from a shelf to read, and then Janet chooses a book from the remaining books that are left on that same shelf. And so this is the key. The books that remain. Did John replace this book? It doesn't say that he did. It just says that John chooses a book, and then Janet chooses books from that same shelf that are remaining. And so now this would be dependent. So Janet's selection depends on John's, because if she chooses a book at random to select, there's less books now. And so it's dependent because there are now fewer books on the shelf. So there's less books on the shelf to pick from, and so that's why we've got a dependent event. And so that's what you have to really look for, is look to see if they end up replacing the item or not. So let's take a look at this next one here. Here we're actually going to solve. We're going to come up with the probability from these independent events, and so they're telling us they're independent events. And so, and actually, some of them are, some of them are not independent in this case. And it's a little misleading here because they say they're independent, but I know one of them is not. So we'll take a look at this. Drawing a brown sock from a drawer of brown socks, 10 black socks, 6 gray socks, replacing it, and then drawing a gray sock. And so this is the key here. We replace the sock that we initially drew. So we're going to select a brown sock, just one sock, not a pair. So just one sock. So probability of selecting a brown sock. And then we're going to end up replacing. So replace. And so always look for that word, whether you replace it or not. So probability of a brown, then the probability of a, let's see, which one is it? A gray. A gray sock. Okay, so we're going to find the probability of the brown, which is 4 socks out of how many socks are there? Well, there's 4 plus 10 plus 6. So we've got 20 socks altogether. And then we're going to multiply, and now when we're multiplying, because we're selecting one sock and then another, and so there's lots of different choices. So this comes back to that fundamental counting theorem, where we have lots of different choices we can end up making, and so that's why we're end up multiplying these probabilities. So we have a gray sock to pick. How many gray socks are there? There's 6 gray socks. Now we replace the one brown, so we still have 4 browns. We still have those 10 blacks, and we had 6 gray socks to choose from. So we go ahead and change. Let's go ahead and come up with our denominator here. We have 4 over 20. And then we're going to multiply this by 6 over, and we go ahead and add those numbers up. We have the same denominator, 20. So we can reduce this fraction before we go ahead and multiply across. It'll make the multiplication easier. And so we have 1 out of 5 is the same as 420. So I just took out a 4 from each of those numbers. Here I'm going to divide this by 2 over 2. End up with 3/10. So I go ahead and multiply. It's a 3 out of 50. 3/50ths is the chance of selecting a brown and then replacing it and selecting a gray. Well, taking a look at our last one here, we've got drawing a pair of black socks from a drawer. Now, black socks, that means I'm taking it as pair, meaning 2. So we got 2 black socks that we're going to end up selecting from a drawer of 4 brown socks and 10 black socks. 6 gray socks. So 4 brown, 10 black, 6 gray. So the same number of socks, it's just now we're going to just select 2 blacks. So the way I'm reading it, we're going to end up having the probability of a black, and then we're going to end up having a probability of another black. Now, if we say, let's just pretend, I know this says independent events, but we're going to make this one a dependent event. Let's say we go ahead and we do not replace. So we're not replacing. So I'm not going to end up replacing this. And so I'm going to draw 1 black sock. Now I'm not going to replace that black sock. And then I'm going to draw another black sock. So now the probability of the total number of events is changing. So this is a dependent event because selecting that second black sock was affected by the selection of the first one, because now there's less black socks. So we're changing this problem to make it this way, where we're not replacing it, because they didn't say whether they replaced it or not, even though the directions say independent events here, but we're saying they did not replace it. And so we'll go with a 4, actually it's a black socks is 10 out of, and we count up all those socks, just like we had done before, it was out of 20 socks. Now, we go ahead and pick another black sock. Again, we did not replace it this time. So, we now have less black socks. How many black socks do we have? 9 black socks. 9 black socks are left. And this is out of how many? Well, there are 19. 19 now, because we took away 1 of those black socks. So that's why I had to reduce this number here by 1 and reduce this number by 1, because now there's less socks, because I took away 1 sock. So we could reduce this fraction a little bit. 10/20ths is the same as 1 over 2. 9 over 19 can't reduce that one, so we just have to multiply across and we get our answer, 9 over 38. So there's my independent event, and I wanted to do one that was a dependent event, so even though it says find the probability of each independent event, I wanted to do one of each. And so we called this one our independent event. Picking the brown sock and then picking the gray socks didn't affect the other, but here a dependent event does. And so the reason it does is because When we took away that one black sock, we had less black socks left, and so that's why the probability changed. So that's the difference between the two. Part 2 will have some more examples of homework problems.